All right, today we're going to dive into a white paper that puts forward something, well, pretty radical. It's called the Graph-Manifold. And look, this isn't just about some new kind of database. Nope, this is a whole new philosophy for how we and our computers can actually make sense of the world. So let's get into what that really means.
So here's our game plan. We're going to start with the big, mind-bending idea, the core philosophy. Then, we'll see how that idea gets built into a really unique three-part architecture. After that, we'll follow the data on its journey through an intelligent pipeline, see the kind of discipline it takes to build this thing, and finally, we'll ask the big question. What does this all mean for the future of how we interact with information?
Okay, let's get right to the heart of it. The first big idea here is about making a fundamental shift in how we think about data. The whole project argues that we've got to move past the idea that data is just something we store.
And that brings us to the one question this entire project revolves around. When you feed a system information, are you just storing it? Or are you actually translating it? According to this paper, the answer to that question changes absolutely everything.
And this quote right here, it just nails the core principle. The way you choose to represent your data isn't just a technical detail, it's a behavioral constraint. It literally sets the rules of the game for what that data can mean. It decides what can be connected, what can be compared, and what kind of questions you can even think to ask.
So this is where the idea of translation comes in. In this system, when you ingest a file, you're not just saving it. You are actively translating it into different dimensions. You're looking at its structure, like the chapters in a book. You're looking at its semantics, what the words actually mean, and you're mapping its relationships, how it connects to everything else. And, this is critical, it always keeps a perfect link back to the original source.
But, a philosophy is one thing. How do you actually build a system that can think this way? That's where the architecture comes in. It's a blueprint designed from the ground up to enable what they call relational cognition. And this entire blueprint is built on the power of, you guessed it, three. Three distinct but totally interconnected spaces that all work together in harmony.
So these three spaces are called manifolds. You can think of them like different but connected universes of data. First, you have the identity manifold. That's kind of like the system's short-term memory. It knows who you are and what you're doing right now. Second is the external manifold. This is the long-term memory, the massive library of everything the system knows. And finally, you've got the virtual manifold, which is like a temporary scratch pad. It's created for every single question you ask, and its job is to pull information from the other two and figure things out.
Now here is the single most elegant part of this whole design. It's a golden rule. All three of these manifolds share the exact same structure, the same schema. What that means is the code you write to navigate that temporary little workspace, it's the exact same code you use to navigate the giant permanent library. It's this same schema rule that makes the whole thing work so beautifully together.
So we've got the philosophy and we've got the architecture. But how does information actually flow through this thing? Well, that brings us to the intelligent pipeline. This is the step-by-step process the system uses to literally think its way from a simple question to a complex, synthesized answer.
And it all happens in this six-stage journey. First, it projects all the potentially useful data into that temporary workspace. Then it fuses it all together. The really crucial step is number 3, scoring, where every single piece of information gets ranked for how relevant it is. The system then extracts the best stuff, hydrates it with all the original context, and finally it synthesizes all that evidence into one single coherent answer. It's pretty amazing.
Now, the absolute core of that pipeline, the engine's brain, if you will, is one elegant algorithm. It's called the gravity formula, and this one signal is what drives all the intelligent ranking in the system.
And here it is. Now, don't let the letters scare you. It's actually beautiful in its simplicity. Gravity is just a mix of two things. The S is for structural centrality. Think of it like Google's original PageRank. It measures how important a piece of information is based on how many other important things point to it. The T is for semantic relevance, which is all about how closely the meaning of the information matches your question. So by blending these two, the system finds stuff that is both super important and directly relevant to you.
Look, a brilliant idea is one thing, but execution is everything. And when you look at the development logs for this project, you see this deep commitment to building it the right way, with serious discipline. You can see that discipline so clearly in the development phases. Just look at the progression. You build the basic scaffold first, way back in phase 1. The core intelligence, the scoring, that doesn't even get touched until phase 5. The full pipeline isn't put together until phase 9. It's this methodical, layer-by-layer approach that makes sure every piece is rock solid before you build on top of it.
And this whole approach is perfectly captured by a principle they call the strangler fig pattern. You know how a fig vine slowly grows around an old tree, eventually replacing it? It's the same idea here. Instead of trying a risky, all-at-once rewrite of old code, you carefully extract one small, well-defined piece at a time. It's a slow, deliberate process that's all about building things correctly, not just quickly.
And what do you get from all that discipline? Well, by phase 11, the system is being validated by 445 separate passing tests. This tells you it's not some fragile prototype. This is a testament to real engineering, a system that's built from the ground up to be stable and reliable.
So let's pull this all together. We've looked at the philosophy, the architecture, the process, and the incredible discipline behind it. What's the big payoff? Why go to all this trouble to think about data in a completely new way?
Well, it all comes back to this core idea. By translating information into its relationships, we can understand it on a much deeper level. And it turns out, graphs are the perfect way to do this, because with a graph, the very shape of the data, the structure itself, is the meaning. The form directly expresses the relationship.
And that leads us to the ultimate takeaway here. The graph manifold isn't a database. It's an externalized relational cognition space. I know, that's a mouthful. But what it means is, it's a tool for thinking. A space outside your own head that's built to understand relationships and context, not as an afterthought, but as the most important thing. It reasons about the world in a way that's much closer to how our own minds work.
And that leaves us with one final, and I think pretty powerful question to chew on. When our systems can finally move beyond just storing files and actually start to think relationally, what new kinds of problems all of a sudden become solvable? What challenges that seemed impossible are now maybe just within our reach?